Hi, in this project, basically, I have developed the traveling salesman problem in MATLAB. The complete problem is identified from theory to implementation in MATLAB, basically. In the traveling salesman problem is basically the quintessential challenge in combinational optimization and operational research where the objective is to determine the shortest possible tour that visit is a set of cities and returns to origin city basically. So in this project basically I have developed the complete problem identification complex optimization problem which involves finding the shortest possible route that visits a set of cities returns from the starting point basically. Despite its simple formulation, we have used the TSP is a computational complex and belongs to the class of NP-hard problems. So in the complete MATLAB implementation, we have just practically optimized the problem of researchers basically theoretical understanding and practical implementation of the complete traveling salesman problem, which provide us different tools like for researchers, for practitioners, for to tackle the routing problems factor. Basically, in this problem, we have just solved the map routing problem. Okay, we identifies how map people search the map shortest route and exact route from one place to another place. So I have just written the abstract with introduction like how it works according to different places from one place to another place. Like for example, this one is the US traveling salesman tour. The salesperson is just started from one place to another place with the movement in different areas like these are the red orange dots basically represents the stays of the stay salesman basically. Yeah. Okay. So yes, the formulation and complexity basically identifies here. In the first of all, we have just added the formulation and complexity, like how it is hard to identify the from one city to another city, how it visits from complexity arises from the need of visit each city exactly from one and then return to starting city basically, then exact methods what he used and then heuristic algorithms. Okay, the problem statement is here and then the methodology is placed here. We have used basically the MATLAB optimization toolbox to obtain an optimal solution. Okay, so the next one basically is the yes in the structure of MATLAB code. Like the structure of MATLAB code, we have used basically the map city of US city, US border data. We collected the US border data in terms of mat file, which contains the coordinates of x-axis and y-axis. Then it generates random cities location and then provide us the different locations according to the distance from each pair of cities using the hypot function. Then it provides us the formulating the TSP means the code formulates the TSP as an integer linear programming according to interpolation with the interlink prog function basically. Interlink prog basically is the function which which provide us the returns place, like it check and balance like how it starts from one place to another place. Okay, Then the simulation setups are added in it, and then key functions, variables, and the insights observations with the advantages of traveling salesman person with the limitations as well. Potential applications, results, and discussion also added according to different tools, according to different distance and time, route optimization, comparison with other methods as well. Okay. So this one is basically the MATLAB identification of city locations with longitude and latitude basically. Next one is the use border and city locations basically identifications. And the third one is we have added the graph of city connections basically, cities connection basically. Next one is basically we have added the solution and subroutes, like how we move from one city to another cities and how it connect each other and how we come back to the original city like where we started. And next one is basically solution with subtour eliminators basically, like we have just connected the roads from each other to solve the traveling salesman problem. Then the distribution of distance according to different frequency level, like distance in kilometers basically. And then we have just added the coverage of distance over its iterations according to traveling salesman solutions, absolute gaps, and yes, this one basically the absolute gap and the complete traveling salesman problem visualize the computational efficiency of each method, and which will allow for a direct comparison of their performance according to the examine of plot. One can gain insight into the trade-offs between solution quality and the computational time. So here is the future work, like how we can extend this work to like to widely used for its efficiency, its effectiveness. Like for the researcher purpose, we can use the genetic algorithm in future as well to simulate the annealing and ant colony optimization to solve the traveling salesman problem. Another area we just also improve this research in learning machine learning algorithm to predict the traffic patterns and roads conditions, and we just provide us a real-time data analysis as well. Okay. Then I have added the conclusion and the references as well. Let me just show you the MATLAB code for that as well. Okay. Yes, this one is a MATLAB code basically. Yes. This one I think is the MATLAB. Is open here. We just, yes, this one is the open MATLAB code. Okay. Here is the MATLAB code we have used in, and yes, this one. Okay. When you will run it, you will get the outputs like this. Okay. If you need to ask, you just ask me. Thank you.